Assalamualaikum, very good afternoon to all. So, let's see how it goes. This one, starting this week, we have repeating classes at night. I'm not sure if I can tolerate night class. Because tired working like from morning until late night Okay. Anyway, let's see today But most of the time for night class, because we don't have the whiteboard, I'm going to sit like you. So we are going to sit in front of, you are looking there, I'm looking here. Okay, and you are going to, I'm going to write here, you're going to look there. Okay, while writing, then you write also. Okay, so today will be we haven't finished chapter 3. Reason why. Okay, last Monday, yes, last Monday we did all of the discrete time for the series, and then we didn't do example 4, but I did ask you to watch the video. So who watched the video? Raise your hand. This example. Who watched it? Basically, I share the link in Telegram lah. I asked you to watch 3 video, I think. 4, 5, 3, 4, 5, I think. Who watched it? Raise it 90 degree. Okay, so maybe half of the class can understand what I'm talking today lah. Okay, and what the example that I'm doing today is actually related to Fourier transform. Fourier transform is chapter 4. Chapter 4. And now we are in Fourier series, and later we are going to chapter 4, Fourier transform. Fourier series and Fourier transform is like siblings. Siblings lah. So if you don't understand here, you don't understand there. Okay. And starting for today, I'm not going to repeat again chapter 1, 2, because there are some students complaining that we've been repeating it. Okay, well, okay. Move on with that. So who don't understand, come and see me. Don't. If you feel that you understand, then don't come and see me. And I pray to God that you pass this subject lah. Okay. But I'm not going to repeat lah. So I'm going to go very fast, year 5 directly, because we have like 2 chapters more to end. But if we proceed without any backtrack to chapter 1 and 2, I presume that we are going to finish on time. Okay, on time. Means that if I ask any question, no, and then we can proceed. That's how we finish on time. Okay, but as you know, if you don't understand in class, go and watch the video. Right? Because we are so much delay right now. But anyway, we try to finish. Okay, so this one, example 4, will be the last example that I'm going to go through in the Fourier series topic, whereby it's important to understand because it's going to be linked with chapter 4 later on. And in chapter 4, we are going to use Fourier transform equation to prove that what we did here was correct. Because if you look at Fourier series and Fourier transform, if you look at the notes, Fourier transform, if you did print out the notes, you will see that for Fourier transform also have the equation. So basically, we are going to prove both equation, Fourier series, Fourier transform, and by proving that, as an engineer, we know that, oh, that's how the equation was used. Okay, so we can actually use the equation for both Fourier series and Fourier transform together, okay, and prove that what you did was correct. Okay, so in example 4, right, so let's just do a recap. Something went wrong. Refresh. Ada news ke? Kita nak tengok news, berita bulletin utama ke? Bulletin utama. I like to watch news bulletin utama at 8 PM. Lots of information about politics, about accident, about US. Okay. So let's look at very fast recap. Fourier series, yeah? What was the equation that you have learned? Two equation, right? What's the first equation? Sine xt equivalent to AK E J K. Correct. If it's wrong, then you're wrong lah. Basically, I'm just writing what you tell me. Okay. Everyone can confirm this is correct. Okay. First equation. Second equation is what equation? AK. AK equivalent to 1 over T. Baru je belajar on Monday. You just learn it on Monday. You already formatted your brain, 1 over T. Integration of 0 to T xt E minus jk omega T. Betul? Yeah, dt, correct. Why have dt? Why have dt? Because you have this integration. Okay, so you have dt. Why? This integration means that you have dt. Okay? Okay, just delete that. So basically what you just wrote just now is this is for continuous time Fourier series equation. Right? For discrete time. Kejap. Sabar. Sabar. Discrete time Fourier series. But I like the energy at night. Okay, compared to morning lah. Okay, so dt is you have almost the similar equation, right? Two equations. So basically you have n equivalent to summation of Abraham and Ayan. What happened to you guys? Okay, let's see Abraham. Okay, Abraham. Negative infinity AK E JK omega n. Okay, correct. Alright, good. Okay, now Ayan. Let's go. So what's the equation? AK Abraham say no. No. It's that one. Look at the continuous time. That's answer over there. No. 1 over what? 1 over n. 1 over n. N, for discrete time, t become n. And then? Yes, summation of 0. N minus 1. And then? Xn. Abraham, don't feed Ayan. Don't feed Ayan the answer. E minus jk omega n. Okay? Everybody can confirm. Next, I will call the guys at the back. Who? I lupa nama. Vengetesh ada kot? Vengetesh ada kot? I think so. The name is, I think, kind of I repeat it many times juga. Haziq. Haziq. Haziq mana Haziq? Mana? Abang Haziq kita. Haziq. Alright. So, why I'm going to repeat this? Because, okay, we look back at this example. Okay? Example 4 is basically, if you look at the question, okay, the equation, this question is given by a periodic square wave is defined over one period t as the following, basically. So they can actually give you only the equation above. So it means that they give you, where's my pointer? Oh, it doesn't appear there. Here, so they can actually give you only this equation without this graph. So if they give you this equation, can you plot the graph? Can, right? Because if you look at this equation, okay, xt is given by 1, means that a constant value. For t is less than plus minus t over 4. Right? So it means that if you have plus minus t over 4, t over 4 minus t over 4. So you have this one, t value is basically 1 lah. The one here, a is equal to 1. Okay? And the rest of the value is 0 and 0. And because it says that a periodic square wave is defined as over a period of t, then you know that every t is going to repeat again. Okay, so it's going to repeat until infinity, plus infinity, and minus infinity. Okay, so imagine that in your final exam, you're not given this graph, you're only given this equation in this format. So you need to know how to plot the graph. Okay, let's do a quick testing to student. Let's say that you have given the equation here, xt is equivalent to t. For this period. So how do you draw it? It is a RAM, right? So RAM t is from where to where? It starts from 0 here, right? Goes up and minus. So basically you have the signal looking like a sawtooth. Sawtooth signal. So it's going to repeat again over a t period. Okay, that is the reason why basic chapter 1 is important. Okay, because you might not know later in chapter 3 or chapter 4, you're given the equation and you need to plot the graph. And unfortunately, if you do not know how to plot a simple RAM that has a shifting and a scaling, then gone lah for that question. Alright. So if you look at here, okay, based on this equation, okay, this question, so you're given xt, so this is xt, and the question is almost similar for all Fourier series. After you do lots of exercise, what do you notice for chapter 3? Normally, they ask you to find the Fourier coefficient, right? Which is Fourier coefficient is AK value. And then, what else do they ask you to do? Okay, until certain point, that was correct also. Okay, and then draw the phase and magnitude and phase spectrum. So basically AK, the magnitude, and also the phase spectrum. That's one thing that normally they ask. And another thing that you can see here, so that the two question is basically question 1 and question 2 lah. Okay, and if you look at number 3, this is additional that they might ask you. Okay, so basically if you're given this type of signal, normally they ask you another type of question. Find the closed form and open form for the Fourier series representation of xt. Okay, so these are the questions that normally for Fourier series. So you cannot go wrong if you understand Fourier series. and the basic signal, shifting, time scaling, and time reversal. Okay, but if you don't, you are confused about the fundamental, then this one you going to be confused, right? So we go to the exercise. Chapter this one, Sembunyi Kenapa macam tiba-tiba sembunyi? Tidur ke semua? Tak kan? Dia macam so quiet, silent. Alright, so let's look at this solution. Okay, step. Just now only not half of the class raised their hand, so most of you guys didn't watch the video, or maybe you don't understand the video. Okay, that's why you don't raise your hand. But anyway, we go through this because this one will be important later. We are going to compare with Fourier transform. Okay, so the first question. Okay, so ask you to find the Fourier coefficient. So Fourier coefficient is basically what? AK, AK, the Fourier coefficient. So they ask you to find AK, and basically here is until the fifth harmonic. Reason why, if it's a periodic signal, means that it's going to be until periodic infinity lah, plus and minus infinity. So of course we need to put a limit for you to calculate. If not, we don't have enough time for 3 hours. So we ask you to only calculate until fifth harmonic. So fifth harmonic basically K equal to what? K is equivalent to plus minus 5. Okay, means that you're going to calculate from K equal to 0, then K equal to plus minus 1, K equal to plus minus 2, K equal to plus minus 3, K equal to plus minus 4, and until plus minus 5. Okay, so based on this, what are the equation do you think that we are going to use? Which equation? Equation number 1 or 2 just now? Equation number 2. What's the equation number 2? Testing only. Okay, so what's the equation? YAK, because we want to find the Fourier coefficient. Okay, if you look at this one just now, we just salah pula, please. Sorry. Wrong paste the previous whatever I copy. Oh man. Dah tak boleh kot. Dah tak boleh. Tak apalah. We write again Alright. It's okay. We write again because practice So we use the second equation. First equation is xt, right? Blah, 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 blah. Second equation is ak. Okay, and so on. So we are going to use the second equation. So ak value is 1 over t, integration of 0 until t, x t e minus j k omega t dt. Okay, so we are going to use the second equation. So I'm just going to remove this. Okay, second equation. Okay, if you look at this, okay, in the equation, what are the value that you can actually get from this graph? T, what else? Kita tengok video kan. What else? The range, which is what range The range lah, which is 0 to t lah. Same thing Okay. Okay, and then what else do you have? K, no, not yet. From here. from this graph? xt, xt. So you need to actually list out what are the value that you have. Okay, so first step that I would suggest is that list here. So what is the t value? T equal to, what is the t value? What's the t value that you have? If it's hard for you to look at it, we take it from 0 lah, 0 point. 0 point, you have this one. It's going to have the full cycle until this point. So t equal to t lah, which is, like, let's say that if t is equal to t, then let's say t equal to t lah. Okay, for this case is t equal to t, but let's say that this one is equal to 1. Okay, so this one is minus 1. So we can write it as t equal to 1. Let's see, right? If there's a value. But right now we are going to use the, we are not going to substitute any value of the t here, let's say, okay, and then from this equation, you can see that you have 1 here. And basically, 1 is amplitude, whereby this one, it says that t over 4, less than t over 4, and more than t over 4, right? So that's where actually a here is equal to 1. So you can write directly, what is actually a? A is actually the value xt lah, over here. And the xt value is between minus t over 4 to t over 4. So you can write directly the value for this case is xt. For this case is, you have 1 also, right? But for the sake of, we want to look at the equation and come up with a general equation for AK. So we are going to directly find A0 first. Okay, so the equation, the question say that, question A say that find AK until fifth harmonic. Okay, harmonic, So until fifth harmonic, so basically, you're going to find it from k equal to 0, plus minus 1, plus minus 2, plus minus 3, plus minus 4, plus minus 5, So those are all the values. So basically, total you will need to calculate 10 plus 1, 11 value, right? So let's find first for k equal to 1. So let's say for k equal to 1, which is DC term, okay, DC term, so you get A0, okay? So what's it mean by DC term? So when you plot Fourier series coefficient, you have the k value, you have here 0, right? Okay, 0, minus 1, 1, 2, minus 2, 3, minus 3. Okay, DC term, okay, the one here that I write is, kenapa girls? Tadi dia tersenyum, ada benda apa kat muka saya ke? Ada bedak ke apa? Tak ada. Tak tahu, dia macam tersenyum kan. Ada something ke kat muka saya ke apa? Okay. Ada something happen ke? Tak ada. Okay. K equal to 1 is basically here. Okay. Kalau ada apa-apa kat muka saya, bagi tahu lah. Janganlah pula tersengih-sengih kat belakang tu. Okay, k equal to 0. Okay, k equal to 0 is over here. And this is basically DC term. Okay. So DC term normally you won't get it in terms of any phase value lah. This is just a constant value, a number. Okay, it can be 0.5, can be 1, 1.5, and so on. DC term. excited. Lepas tu, the rest, okay, here, we call it as a harmonics. Harmonics. Means that plus minus 1, plus minus 2, plus minus 3 until infinity, all are harmonics. But we also have a special name for k equal to 1, which is k equal to 1, okay, we name it as k equal to 1 is the fundamental frequency. Okay, so in a question, for example, the fundamental frequency for the magnitude is is increased by 50%. So you need to know what does it mean. Means that at k equal to 1 lah. Okay, if say that for the harmonics more than 3, okay, and above, the magnitude is going to be less than 40%. So everything from plus minus 3, plus minus 3, plus minus 4, and so on is going to be reduced by 40%. The other don't change. Example, like your assignment, right? Okay. So for A0, so that's why we are going to start, when we start to calculate for Fourier series, we are going to start normally from k equal to 0 lah. Don't go and start from k equal to 5. Okay, start with k equal to 0, the DC term. So A0, if you look back at the equation, so every time when you want to actually expand and calculate for the Fourier coefficient, kejap, best dia jadi auto square. Okay, walaupun tadi lukis not so good. Okay, so A0. So if you look at A0, we are going to expand the equation above. For the case of, let's say, I'm going to write, since tadi siapa Izzah dia bagi tahu tadi equation dia memang sama ada you put there 0 to t, or you can put there minus t to minus infinity to infinity, right? For one period, so basically minus infinity to infinity. But basically when you put like this is, you need to identify one cycle or one period. So normally I will put there 0 to t only lah. Okay. So you don't really need to care much about the value. Okay, so 0 to t. So but let's say that we are going to expand based on this equation, then let's expand it. So if we expand it, we have here, okay, AK is 1 over t. Okay, so we keep it 1 over t. So 1 over t. Integration, you just follow it. Okay, integration, and you look at integration is, we are going to only pick up one cycle. Okay, then after that it's going to repeat. Okay, so if we look at this point, this graph, you have basically 2 cycle lah kan, 3 cycle here, inside here. 1, 2, 3. Okay, 3 cycle. Can you understand or not how to get that 3 cycle? Bagus, ulang balik. Okay, 3 cycle. We start from here. 1 cycle. 2. Okay. 3. Alright, but here it shows 3 lah. But of course we can do it until infinity, plus minus. But in this equation, when we want to expand the Fourier series, we are going to look only for at the 1 cycle only. Okay, so if we look at 1 cycle, let's just remove that so that you don't get confused. If you look at this, let's say we want to do the integration. I'm going to integrate it. So 1 cycle can be actually labeled as the first way just now, or I can label at this point. One cycle. Boleh tak? Boleh kan? So one cycle. Another cycle is like this, right? And then another cycle is this one. So is this the same? Because you're going to repeat. Okay, so you define it whichever it is, it's okay. So from here is that let's look at the blue plotting that I highlight. So blue plotting, what is the integration value? From minus t over 2 to t over 2, because we are going to pick only one cycle. Okay, but if you look at from minus t over 2 to t over 2, you can see that actually at this point only, between minus t over 2 to minus t over 4 to t over 4, you have a value, the amplitude, which is 1. The other value at this point and this point is 0. So basically, when we do integration, we want to integrate only the value that have the area beneath it, right? So we can rewrite this equation, because in the end, we are going to substitute xt value. If we have xt value at 0, then no point to do integration. It's still 0. So we are going to, basically, when we use this equation, I would advise just look at the point that have the amplitude value. Okay, for one cycle, which part that have amplitude? Okay, so if you look at this, even though the blue plotting is from minus t over 2 to t over 2, but which part that have an amplitude? From minus t over 4 to t over 4. Alright? Can you understand that? Very slow to explain one by one, but this need to be explained. Okay? And then this one is just first one. And what else? Next is you're going to substitute the value for xt. So what's the value for xt between minus t over 4 to t over 4? 1. But let's say that we are not going to substitute that value first. Okay? So let's say we just assume that we are looking at this signal graph. Okay? So the amplitude is A. So we put there A, E minus J, K, omega, T, D, T. Alright? Can you understand this one? So just substitute the value for T, because from the graph it shows that the time is, one period is T. If the period is 1, then we substitute 1 into the value for T. Okay. For xt right now, because it's state there A, then we are going to substitute A for now. Right? And the rest, we just write it first. Okay. Now, we are going to do integration of exponential. So, if you remember in convolution integral, okay, convolution integral, integration of at dt, what do you get? Dt, what do you get? EAT over T. EAT over A, right? Okay, integration, convolution integral. Go and check again the notes. So this one, when you go into the exam hall, write the equation. Okay, integration of EAT dt equal to EAT over A. So Right now, if you look at this one, k equal to 0. Can you substitute this one? Okay, can, right? So k is equal to 0. So we expand this. What do you get? 1 over t. Exponential. Integration of minus t over 4. T over 4. A e 0. Okay, dt. So what do you get? One over t minus t over 4. T over 4. A 1, right? So y1, this one is equal to 1. Okay, and dt. Integration of constant value, what do you get? Integration of constant value. Integration of a. Example, dt. What do you get? Yeah. You get a t, Right, so we can actually solve this one now. So you get 1 over t. So a, we get a t. T over 4 minus t over 4. Okay. Let's bring a over here. So you get a over t. Okay. And then you have t. Basically, this one t over 4 minus t over 4. Expanded a over t. T over 4 minus t over 4. Okay. Can everybody follow? Anyone lost? Okay, this one is just a I bring over here so that you just only look at t only. So constant value you can take out over here. So a over t, this one is not 4, is a. This is a. Okay, a over t. In square bracket, t over 4, so you you substitute into this t. So you have t over 4. Okay, minus, substitute this value. Minus t over 4. Okay, if you're professional at it, you should be able to write it as 8 over t, t over 4 plus t over 4. You should able to write it like this, nah? And then expand again. So you get 2t over 4. Okay. And you got the answer A. Oh, this one is, okay. So you get A over 2. Therefore, A0 is equal to A over 2. Okay. This one is only A0, Okay. Only A0. Right. Of course, what if you ask doctor, so A over 2. So how do you plot A0? Well, normally in the exam, A value is given. Is given with a constant value, given 1, 2, 3, 0, 4, 5. So you just substitute in the equation. yeah, you can also put in a graph. If not given, then just plot it A over 2. Okay, but if it's given, then you need to substitute the value of A. Okay, so you can do it at the end here like this, or you can do it from the top. From the top means that from this part already you substitute with 1. Okay, so you still get 1 over 2. Alright. Okay, that would be A0. Now we are going to do the tricky part. So for we call it as k not equal to 0, which is the harmonics. The harmonics. So harmonics. Okay, which means that for k equal to plus minus 1, plus minus 2, plus minus 3, plus minus 4, plus minus 5. We are going to get the general equation. A general one equation for a k value for k not equal to 0. Alright. So we put here. Okay, we start to use the same equation. Okay, the equation so write first ak value. Ak k equivalent to, I'm going to write the normal the general equation first, so that because it's going up just now. So from 0 to t xt e minus j k omega t dt. Okay.
So this one we're not going to use the negative t over 4 now. We're not going to use the range negative t over 4 to t over 4.
Of course we are going to use it. But for this, I'm going to write it over t. It's either one lah, same lah, minus infinity to infinity, or you can write it 0 to t, same thing, because we are taking about one cycle. Okay, so you can write that, but anyway we stick with the minus infinity to infinity. Okay, so for the non zero harmonics, okay, so you expand it. Okay, start to fill in the equation again. So we still keep with the t value, which is are you going to substitute or not? Okay, we don't substitute it, we keep it with t and a. So 1 over t integration of minus t over 4 t over 4 xt is a e minus j k omega t dt. Right? So now since all of the value we cannot substitute it, right? We are not going to substitute it. T is already t, xt already a, k we are not going to substitute with any of the harmonics yet. Okay, we are going to get the general equation. So right now we are going to integrate this one. Okay, so to integrate this e minus e exponential value, so you look at first in the integration part, since we have the constant value, so we take out the constant value so that you don't get confused. Okay, this constant value, take it out to the front. Okay, so write again the equation. So a over t integrate minus t over 4 over 4 t over 4. Okay, so a already bring up to the front. So we are going to write e directly. E minus j k omega t dt. So now we are left with exponential value. So using the equation just now, integration of e a t dt, what do we get? E a t over a. For this case, what is your a value? So a here, okay, is basically the whole thing here. Okay, this one is a. Okay. So you're going, oh, tak boleh naik. So now we expand, we integrate here, 1 over t. Okay, E minus jk omega t over minus jk omega. Right? Correct?
In bracket.
Hmm?
In bracket.
Betul tak? Kan? And then t over 4 minus t over 4. Please correct me if I'm wrong. Because it's already like late night kan. So sometimes the positive become negative, negative become positive. Alright? So you have this one right now. Okay? So if you look at this, we are going to expand it. Expand t, substitute with t over 4 minus t over 4. Alright? So before we do that, so that to avoid you getting confused, so we are going to take this. Oh Allah, dia nak jadi itu pula. Okay, tak apalah, biar je. Okay, that square, take it out to the front. Okay, so we write it as A minus J K omega T. Right? Okay, in bracket. Okay, can I just skip directly and substitute T over 4 to T, because it's taking too long, Okay, so E minus J K omega. So T value here, you're going to substitute, use this value, So we have T over 4. Okay, and then what? Minus E minus J K omega minus T over 4. Yang tu boleh faham ke? Faham? Okay, bukan bosan Okay. Alright. So, if you look at this equation, what do you think? What type of equation that you can use to actually convert it to a simple equation that you have learned in the beginning of chapter 3? Euler identity, So, Euler identity. Euler identity, you have two equation, right? So, the first one is cos. The first cos, Cos theta is equal to 1 over 2 E J theta plus E minus J theta. Another one is sin theta 1 over 2J E J theta minus E minus J theta. Okay. So we are going to compare between cos theta and sin theta. What does this can be transferred to? Sin. Why? Because underneath here you have J. Right? So basically, if you look at this equation, you need to put in terms of sin theta. Theta is what? This one. After J, you have all, whatever inside there is theta. Okay? So theta. So what's your theta over here inside this equation? It's K omega and the rest. Okay? So this one, actually, if you rewrite, you can get positive, Can we rewrite it again? I don't want to rewrite it because too many ni. So I'm just going to delete this. Minus and minus become positive, So this one become positive. Okay. So therefore, then you can see that, oh, you have J over here. J and J. Yeah, J. Okay. And then you have this one is E plus. You have plus. Then you have E minus. Okay. So what you need to do so that you then don't get confused is that rearrange this in the correct arrangement lah, so that it looks like sine theta. Okay, so and if you look at this also, what is your theta? Theta is equal to, from this equation, k omega t over 4, right? So basically what you want to do is that you need to actually take out, make sure that you have this point, this in front, and then you need to leave the bottom part, okay, the numerator part here, 2j. So do you have 2j over here? So if you don't have 2j, what do you do? Multiply by 2. Okay, so you have j, but you don't have 1 over 2, right? So basically what you do is multiply 2 over 2. Okay, so multiply 2 over 2. So I'm going to rearrange again so that it looks like the sine theta. So a, okay, minus, wait, let me see, minus k omega t, okay, and then you have 2j, correct, right? Because you have j over here, k omega minus here, t, right? Correct, eh? And then a, 2, basically you need to write 2a lah, okay, because 2a. Okay, in bracket, I'm going to write it like this, 1 over 2, e minus j, no, e j k omega t over 4, okay, minus e minus j k omega t over 4. So basically this one, I rearrange it, swap it, this one I already swap it to the left side. But do you think the negative, if I swap, this one become positive, right? Okay. Originally it's negative, but because we swap this one in front, we have negative here, right? So negative multiplied by negative become positive lah. I get so confused faces, eh. Okay, then I'm going to write it full. Wait. Maybe the way I write it does confuse you. E j k omega t. Which one is this one, right? Okay, so you have negative lah, put there negative. Then you have positive here, you're going to reach here. So plus, or this one over 4, don't forget. E minus, not minus, positive, this one. Betul lah, apa ni, sorry. Minus j k omega t over 4. Close bracket. Okay. Negative, right? Negative. Negative times negative, positive. Negative with positive, negative. Can understand or not, Wait, This one. Ow. This one, This one and this one. I swap it, Swap. Everything that have it, EJ plus E positive with the minus here, I swap it in front. This one, bring to the back. But you need to know that if you want to use it in terms of sine theta, you need to have it EJ theta, which is this one, is positive. And this one is negative. And we are so lucky that there's a negative here. Luckier for us. So this negative means that whatever you have here become the opposite, right? So negative and negative become positive. Negative times positive become negative. Can understand that or not? Can eh? Okay. So I'm going to just rub it here because if not, okay. So you have minus. Alright? Okay. Can understand that? Alright, so this one. So basically, this what we did just now was we want to put it in terms of sine theta, right? Your theta is what? K omega t over 4, right? So basically, we write it as sine K omega t over 4. Okay? So the equation will become 2a over K omega t sine K omega t over 4. Let me check my answer. Correct or not? 2a K omega t sine omega t. Right? Correct? Okay? And basically, okay, we know that you have learned in the beginning of chapter 3 is omega equal to what? 2 pi over 2 pi over t. So you can substitute this. Substitute it. 2a k omega 2 pi over t sine k 2 pi over t over 4. Betul tak? Cuba check. Because I normally make mistake kan. So we check. Okay, so basically we can cut off some of the value, right? So t come 1. t 1, 2, 1 and 2. What else here, right? 2, 2. Anything else? Anywhere else? No, right? Okay, so write it as a over k pi sine k pi over 2. Okay, this one ak. 4 k not equal to 0. So basically what you did just now is to get the equation for AK for harmonics. Right now, you already know that for AK, they ask you to actually find it until fifth harmonic. So please calculate using calculator. Substitute what? K, right? So you have K equal to 1 plus minus 1 until 5. So substitute it and get the value for A what plus minus 1 until 5 right now. Do it. I give you 1 minute. Maybe 5 minutes lah, 5 minutes. Calculate there. Always bring calculator when you come to signal system, Okay.
No, for A, do we assume that?
Oh yeah, okay. For A, let's say that for this case, A is 1. A is 1. Okay. So for this case, find AK value, and assume, let's say that because we want to plot, so assume A equal to 1. Okay. So find A0, just now A0 already found, right? A0 is what? Substitute lah. A over 2, right? So you get 1 over 2. Right? So list out everything. A0, what? A plus, A1, what? A minus 1, what? Okay. Dah start pun payah. Okay. A0. Nangis saya tengok. Nak tekan calculator tak tahu kan. Okay, just now, what did you do Actually, the question was to find Fourier series coefficient, right? Okay, Fourier series coefficient, and then you start with k equal to 0, which is this term. This term, substitute lah a equal to 1 inside this equation. What you get? A equal to 1. 1 over 2. Dah. Settle. K equal to 1. No. A0. A0 just now. The equation we get A over 2, right? Okay. And then A0. Substitute, you get 1 over 2 lah. Okay. Done Now, I ask you to find for k not equal to 0. Alright, guys, at the back there. Okay, and then we did a very long derivation. Okay, we expand the equation using the Fourier transform. Okay, we did this long derivation, blah 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 blah, until we get this equation. So what it means that, okay, you start with k equal to 1, Let k equal to 1. Therefore, A1 equal to, A substitute with 1, 1 over k, 1 pi. Sin, k equal to 1, 1 pi over 2. 1 over pi, sin, pi over 2 berapa? Pi is what? 180, right? Don't tell me you need to press calculator for that. Pi is equal to 180. So divide by 2, you get sin 90. And then now press calculator. So what do you get? Sin 90, you get what? 1, right? So you can write it, leave it as 1 over pi is okay. But if you want to expand it, you can write it as 0.318. Okay? Magnitude already. Only means that for A1, you don't have any phase value lah. You only have the magnitude. Magnitude here, that's the value 0.318. The phase value basically is 0 lah. 0. Or if you want to write it as in rectangular form, means that plus J0. Try to press calculator, you get 0.318, 0 degree, same thing. Alright? Okay, so you don't need to do that. Just leave it up until this one should be okay. Alright? No need to do extra. Because you have lots of things to do. For the series, you don't need to do extra work for that. Then we continue. K equal to minus 1. So, minus 1, then substitute K value. And press calculator. And then find it again. Okay, so do it until plus minus 5. Now, start. I punya calculator bukan radian dalam degree lah. I punya zaman 21 tahun lalu lah. So, dia punya yang calculator cost KC only 1,000. So, mode is complex. Make sure your mode is complex. Because complex one degree Alright, then at the back. Okay, let's check your answer. So, A minus 1, what do you get? You also get 0.318. A2? 0. A minus 2? 0. A3? Let me just write it. Wait. Okay, A1 just now is 1 over 5 or 0.318. Okay, A2, A minus 1 is 1 over 5 equal to 0.318. Okay, A2, A minus 2 is 0. A3 is minus, means that you get minus 1 over 3 pi. 3 pi, which is minus 0.106. A minus 3, same, so minus 1 over 3 pi equal to minus 0.106. If 4, you get 0. So basically A minus 4, get 0. A5 equal to A minus 5 also. You get 1 over 5 pi 0.0637. Okay, so did you get the answer? Anyone who didn't get the answer, the next student next to him, please check his answer. Okay, please check your friend's answer. Okay, so what we do after this? So basically, if you look at the question, what you did just now was only question number 1. So now you need to plot the amplitude spectrum lah. So basically here, why? Because you don't have even the phase spectrum, right? So amplitude spectrum. So, but if you have the phase spectrum, then you need to plot the phase spectrum also. So normally they will write there, sketch the amplitude and phase spectrum for xt. Okay, so plot it. Plot it. So how to plot it? Do a like that. Okay. Omega 0, 1, 2, 3, 4, 5. Minus 1, minus 2, minus 3, minus 4, minus 5. Okay. Okay, now A0 was 1 over 2, right? Which is 0.5 lah. So let's say 0.5 is here, 0.5. Okay. A1, A minus 1 is 0.318. 0.318. 0.318. Okay. A2 is 0, 0. A3 is minus 0.106. So it's negative. So minus, let's say here, minus 0.106 minus 0.106. At 4 you get 0 again. At 5 you get 0.0637. So basically small one here lah. 0.0637. 0.0637. So basically, if you actually did it until 50 lah, 50, let's say, you pop until A 50 and A minus 50. Okay, so basically you get a graph maybe looking like this. This one, if you look at it, oh, the infinity 0 ah. Okay, so this one, pop. So basically, if you look at this signal, for even signal, the AK value is 0, right? For odd signal, there's a value. Okay, so if you look at this, what type of signal? It's a sync signal, sync. S-I-N-C. Betul lah, S-I, sync. S-I-N-C. S-I-N-C. Okay, so how do you convert sync, sine to sync? Any idea? Sync, S-I-N-C, equivalent to sine. Huh? What? Ada apa? Sekejap, tertinggal tita situ. Tertinggal tita. I also confused why it's only sync there. Okay. So, this
Where that come from?
this signal, if you see, if I connect all it, this is called envelope. Is envelope the signal coefficient, so envelope, and this type of signal, if we have it a peak here at 0 and then it goes to infinity, this is a type of signal we call as sync. S-I-N-C, sync. If you Google it, type sync, and then you will get this type of signal. Okay, until infinity it goes to 0, minus infinity it goes to 0. Okay? And according to the equation in mathematics, sync theta is equal to sync sine theta over theta. Okay? So, if you look at the equation, where's the equation? This one. Can you actually convert it to sync? Can you convert it to sync? Abraham, can we convert it to sync? Hey, guys, you have sign over here, right? Huh? No, not yet. No, it's not. AK is you get the coefficient, but the graph is not in terms of sync. Okay, you want to convert that signal into sync. Reason why? Because it's later related to Fourier transform. Fourier transform, mostly you're going to use sync. S-I-N-C lah. Okay, so let's just convert it so that later we are going to use it. Lucky that we use this whiteboard, then I can just open this later on. Okay, so this one, if you want to convert to sync, what do? You need to have the theta, sine theta over theta. So for this case, what is your theta? Your theta is equal to k pi over 2. So do you have the same one here? No. So how do you actually make it into k pi over 2? You need to AK equivalent to sin k pi over 2, okay, which is 1 over k pi over 2. Basically, what is it? You need to have 2 up, right? Okay, on top, so it's the reverse of that lah. Okay, so you need to have 2 here, right? So basically, you just multiply 2 over 2 lah. Same thing juga lah. Divide by 2 over 2 is same thing with multiply by 2 over 2. Okay, so in this case is that you're going to multiply this is by 2 over 2 so that you get 2 over k pi. Okay, but if you still get confused, then I'm not going to write it in terms of this. I'm going to write it in terms of the equation just now. Okay, so since theta is k over pi, so k pi over 2. Okay, and then you have the original here, you have a over k pi. So a over k pi. So k pi, you take it to the left side, right, already. Okay, so this one, you don't have it anymore, right? And then because you have 2 here, then you have 2 underneath lah. Okay, right? So you have a over 2 sin k pi over 2. Okay, so this one will represent the equation also in the same way lah, instead of having the equation like this. Okay, so anyway, later this one we are going to confirm back with Fourier transform in chapter 4 lah. Okay, if you still confused, don't worry, I'm going to repeat it again, relate it in chapter 4. So in PowerPoint, I'm going to do the third one. Find the closed form and open form for the Fourier series. Okay, so closed form meaning that you get an equation in a general equation. So this is easy, whereby you're going to use the equation. Means that find the equation. Question number 3 is find xt in term of closed form, okay, and open form. Closed form and open form. What does it mean by closed form? Closed form means that, okay, you're going to get the equation in terms of equation for xt. Okay, in terms of xt, sikit lagi guys, just a little bit, just tahan, bear with me. So xt, you know the equation is what? Summation of minus infinity to infinity ak e j k omega t. Alright, so equation for open form, you are going to use this equation. Closed form, you are going to use this equation, closed form, whereby we are going to substitute ak value that we get just now, the general equation. What was the general equation just now? So we write it as summation of minus infinity to infinity. AK is we assume 1, so we get sine k pi over 2 over k pi, right? Okay, e j k omega t. This is the answer for xt in closed form. Okay. Means that you get a general equation. Okay. For open form, what does it mean? Open form means that you use also this equation for open form. Open form, expand xt, okay, with ak value. Alright? So, xt equivalent to. So, summation of what? So, summation is ak, right? Summation of a0, blah, 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 plus a1, blah, 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 plus a minus 1, blah, 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 until a5 plus a minus 5. Alright? So, we are going to insert a0 first lah. So, what's a0? 1 over 2. Right? This is a0. Okay? This is a0. Now, we are going to insert a1. So, what's a1 just now? 1 over 5. 1 over pi, right? So, 1 over pi. Okay? And then, just insert the equation. Okay? So, we have what? E, J, K, omega, T. Plus. And then we need to insert what? A minus 1. Okay. So we get 1 over pi. E, K is minus 1. Minus J, K, omega, T. Follow me, Follow. Spend only, Who lost right now?
No, 0.5 loss. Well, we need to there. Or do we have to substitute?
Oh, no, yeah. I need to substitute.
Oh, okay.
I need to substitute. Yeah, my mistake. Okay, here, right? So, because you set 0, right? So, K also substitute. So, thank you for that. So, basically, this K is 1 lah. This is K equal to 1. This one is minus 1. Okay, so that's why you get minus here, basically, So, if I rewrite this. What time, we lock inside the library. J omega T minus J omega T, Okay, then expand it until plus 5 lah, Okay, so basically, go and watch my video lah. We are not going to finish it by today, basically, if we still continue. So, blah, 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 until a minus 5. Okay, add it. And basically, you can rewrite it again. After you write it, you notice that you can actually write it in terms of cos theta, the Euler equation. Okay, cos theta. So you get the final equation. I write the final equation answer only, So 1 over 2. So you get xt equal to 1 over 2 plus 2 over pi cos omega t plus 2 over 3 pi cos 3 omega t plus 2 over 5 pi cos 4 omega t. So, this is we call as open form. Okay? Open form. Open form is basically we expand it. Okay? So, if you don't get it today, maybe a bit blur, go and watch the video. Video, I think, part 4, I think. Same thing. You can slow down the video if you want, stop it if you want, rewind it if you want. The same thing, explanation, eh? Okay, so that'll be all for this chapter Fourier series, eh? Tomorrow we are going to, tomorrow morning we have class 11. This week is boring enough to see me every like 4 times, eh? But anyway, tomorrow we start Fourier transform. If you look at the slide, it's almost like 100 pages. But I'm going to try to skip, which is not that important, and means that it's important, but maybe I don't need to actually emphasize it. You go and watch the video lah, basically. Okay, so I'm going to emphasize part that is going to come out in your hand. Yeah, but the story behind it need to be explained. Alright, so see you guys tomorrow at 11. Thank you. Assalamualaikum warahmatullahi wabarakatuh.